Hello, so I'm going to go through another project on TinkerCAD. So log into TinkerCAD, go to 3D, go to Learn, and then click on this 3D thing, change it to Circuits, click Projects. If you're interested in any of the original projects, the first few projects, I've already gone through a bunch of these all the way through color mixing lamps, so I went through these. Now we're on Moode Cue. Now I've also opened up the code from Arduino.cc, and we'll use that in just a little bit. So as always, let's get started. I'm not gonna read all this stuff for you because I don't want to waste your time. You can read it if you want to read it. Otherwise, I'll just walk you through it. This is the Arduino board. This is a breadboard, and we're going to hook up stuff. So you can read this. Obviously, more than welcome. I'm going to fast forward so I don't waste your time. So you'll need a potentiometer, a servo motor, and two electrolytic capacitors, and then obviously your Arduino and breadboard. And it shows how it's set up here. But I believe on the next screen they'll show it even better. So it tells you what a potentiometer is. Basically, it's you twist. As you twist this, it gives out a different amount of voltage. It's a dimmer switch. That's what a potentiometer is. All right. Servo motor is like a normal motor, but depending on how much electricity or opposed with modulation you've given to it, it rotates a certain amount of degrees. So it doesn't just spin, it can move, 45 degrees or whatever we'd like. So let's move forward to setting up the circuit. So those were the parts. I'm going to do this one, I think a little faster. We'll see how it goes. So we'll click forward. The first thing that we always do is hook up our positive and negative. As always, it's important. Let me make sure they wanted 5 volts. Yep, okay. It is important to color code it, right? Positive should be red as designated by that line right there. So we should change this to red, and that's to keep us nice and organized. And then ground would be black. You'll notice that I did not hook it up exactly where they have it. They had it one over. It doesn't matter. As long as you put it in one of these holes, they all correspond to each other. So let's click next. Then what they want is we will take our potentiometer. Now this is a little hard because you can't tell exactly where it's lining up. It's lining up with 11 here, and then 10 and 12. So if you can't find it, you can just type potentiometer. But let's drag this over here. Now you'll notice this one, which is funny, it's not the same. It's not the same at all. And so I'm going to search, but I doubt they have the same one. Yep, they don't. So those are, let's see. Yep, so they don't. So let's look at this picture. The middle one needs to be connected to 11, which runs to A0. So let's move this down. I'll make sure it's in the right spot. So we've got 10, 11, and 12. So 10 and 11 and 12. They've got a wire, which they have, which is red, and it's running from the 11. Because remember, these are all connected to each other. So they had it set up on this section. These would all be connected to each other, and I believe it was going to A0. They made it red. And then all they have is 10 ground, 12 to the positive. Let's double check that that's right. If we mouse over, it says terminal 1 and terminal 2. So apparently this one, it does not matter. It's omnidirectional. So we can ground, and we'll change those colors in a second, and we'll add a positive. So this one needs to be black because it's a ground, and this one needs to be red because it's a positive. These do overlap a little bit. So if you wanted to clean it up somehow, you could. I mean, I won't spend too much time on that. Let me just make sure we're good. All right, cool. So we're good. Then it says, basically just do this. So it's saying 9, and actually let's get the servo in there. Hopefully it looks the same. I haven't done this one. I mean, I did it in real life, but oops. I haven't done it on here. So we've got a servo. Awesome. Now, it's interesting. It doesn't look the same, and maybe there's a way to rotate it. So you can rotate it, but that doesn't really offer us any benefit whatsoever. So obviously in this situation, they didn't set it up 100% correctly. because they haven't updated it yet, but that's okay. So we're going to read this. It says plug into row E on the breadboard in columns 23, 24, and 25. We don't know which ones correspond yet to it, but we can guess. So 25 runs to 9, and then we have a positive and a negative. So I see red, right? Red means positive, black means negative, and then there's something else. So if we go here and we mouse over, we have power, signal, and ground. So we know where those go. Now, I'm just going to hook it up straight to it. You could add it to the breadboard just with how this is. I don't see a need to. So we've got power, so that's positive. We'll run that to the positive rail and we'll make it red. We have ground, so that should run to the negative, and we'll make that black. And then according to this, they had the signal, which was obviously yellow, running to number 9. So let's run this to number 9. And I believe they had it yellow. Is that right? They had it red. All right, I'll make it red. Sure. I would have made, actually, I'm going to do this. I'd make this one yellow, and I would also make this one another color. Doesn't really matter what color. I want to designate between ones that are providing power and ground and then that are sending or receiving signals. So that's up to you. I think you can move, you can nicely move these if that bothers you where it was or whatever once it's wired up. All right, so we have everything there. Let's move forward. Now they're saying how to connect it. Extend the servo motor wires by using a block of 3 male header pins. Okay. So if you're doing this in real life, by the way, you might actually have to hook up a 9-volt battery to your normal little plug here for this to actually work in real life if you're doing it on your Arduino. So you can read through it, but basically, looks like I missed a spot. So perhaps they talked about that in the last one, but let's go ahead and hook these up. They want the electrolytic capacitors, and those were 100. Is that picofaraday? I don't know, pico something. So let's type capacitor. All right, we have polarized capacitors. It looks like that's what they wanted, and I'm not totally sure where they hooked them up. So we've got it in 5 and 7. So we bring this to 5 and 7. Remember, it could be any of these, but keeping it, as clean as possible when you're doing it is nice. And then they have it in 17 and 19. So let's drag that over, 17 and 19. Perfect. Now we have to have a positive and a negative. What they've got, they actually have these. So capacitors, actually, I'll talk about it in a second. Let's do these. I like how they have this. So they've got this running here, and they have it as red. And then they have this side running to there, and they have that as red. Then we've got this capacitor. Now, because of how we set this up, this isn't going to work. Okay, so what we're going to have to do, we're going to have to change a couple steps. So let's do this instead. If we're looking here, they have the negative running to the negative. So let's do this. We'll run this to here. We'll make it black. Then instead of wiring this directly to negative, let's go ahead and get rid of this wire. We're going to run this to there. So now those are connected. And then we can run this to the negative. I hope that makes sense as to why I did that. It's the same circuit as before, but now we're putting in the capacitor, and I'll talk to you in a second about why we want a capacitor in here. Then, and actually I think you can do this without capacitors, but maybe this will allow you to do it without the 9-volt battery. Then we have the positive running to the positive. So then we need to rewire the positive, so we'll erase that. Let's run this. So this is positive, so let's make it red. We'll have to run it to the positive, and we'll run this to, I don't like overlapping them, so I'm going to just do that for you. If I was doing that in real life where this was 3D, I would have plugged it in there just to have it clean, but whatever. Okay. Capacitors store energy. They are used in things like tasers, where they can be used to let out a lot of electricity at once, or they're used in things like sound systems in cars and probably home, obviously home stereo systems to provide a constant amount of power. So if there's a point where somebody needs a lot of it needs extra electricity, and this 5 volts just isn't cutting it, it's able to pull from these capacitors a little bit to be able to get some power. Now, I do think it's interesting how they're hooked up here. I feel like we could have connected them totally different ways. This is going to the negative here, so let me double check that. Yeah. So really, I mean, we could have just run this capacitor to the negative, this to the positive, this to the negative, this to the positive, but they tied it in there for some reason. It's probably because when you're making electrical components, it's nice to have them probably closer to each other for less loss. But these just provide sort of a backup amount of electricity. If I'm wrong on that, please comment. But as far as I know, that's why we would use the capacitors in those. And it probably explains it in here, but I'm not going to spend time on that. Let's make sure they're 100 picofarad or whatever that would be. 100. 100. And this one, for some reason, it's not showing up for me. There we go. 100. And I don't know what voltage rating they want, but I doubt it matters on this one. It might matter, and we might have to go back to that first page later if this doesn't work. So let me click done, and we will move forward to writing the code. As always, I'm not always a huge fan of their code. Their code is typically the same exact code that they use in the Arduino CC, the program. However, it does not include the notes. So you'll see that somehow the servo's in there. Maybe you found that servo. I didn't find that servo. I guess maybe it was in here and I missed it. So I'd imagine it's the same servo, but it loaded itself. So apparently none of what we did had to happen. But if you're doing it in real life, hopefully I helped you better understand. But it's the same exact thing that we're doing. And now we're going to go into the code. Now, I am going to just walk you through the code. Okay, they show you how to go through everything, and I would read this. This gives you some information about some of the libraries and stuff, that's important. But I'm going to just grab the code and we'll go through it. So I'm copying it. I got this by going to create.arduino.cc, .cc, logged in, and then I went over to examples, starter kit, and then servo mood indicator. And then we can click on code here. I'm going to erase everything and I'm going to paste. So as always, this goes through, and Scott, thank you again. Wonderful job. It's withstood many years of use. It talks about what you need and all that stuff, and it has all these wonderful notes, right? Anything past these slashes are just notes, and they're for us to better understand. So what it's saying is, let's import this stuff, this whole library of information called servo. Basically, it's giving the Arduino the ability to know how to interact with a servo. And someone already wrote that programming for you, so it saves you a lot of time. Now, create a servo, and we're calling it my servo. We're creating a constant called pot pin, and that is going to be input a 0, which is analog, so it receives a certain value. It's not like on or off like digital. It's a value between 0 and, I don't know, 2000 something. I always say that. I'm sure there's an exact answer. And then they're saying there's this variable we're going to call pot val, and this other one called angle. Now, a couple people have asked in previous codes they had written =0. Here's our proof that we don't need that. Now, void setup, this is something that runs one time when it turns on or when we hit the reset button, wherever that would be. I don't see it. Oh, right there. Maybe that's the reset button. So it's saying, hey, my servo, which we defined as servo, right? And it already knows how to deal with servos because it grabbed it from the library, that we attached it to pin 9. So the servo is attached to pin 9. Then we open up the serial. This just makes sure that we can get information. So then when we do our simulation, we can look on our serial monitor down here and get some information. This is a nice, easy one. So then it's just saying, hey, read pot pin. So read A0. Is that correct? Yes. Read A0, right? Let me get there. Sorry, I lost my spot for a second. Read that, right? Read it and save it as pot val, and then print it out. So say pot val, and then it's whatever we want written with a space, and then it's going to say the number. So down here it will say pot val, and it'll tell us a number, and then it's saying to scale the numbers. So they're saying angle, which we already made a variable up here. Angle is equal to. So they're saying. Cool. So maybe it's 0 to 1023. So this is basically making it a more readable amount. I would look up a tutorial on this map. I don't feel qualified to talk to you about that one right now. So I'll put a link in the description to describe exactly what's happening here. And then print out the angle for the servo motor. So serial print, it'll say pot val, it'll say some number, and it's going to say angle, and then tell us the angle, and then set the new server position, wait 15 seconds. Let's run it. So now you'll see as we turn our potentiometer, it should turn our servo. All right. So what it's saying is pot val, which is taken directly from here. Okay. It is giving this value. And actually, let's see our highest value that we can get. Awesome. 1023. Let's see our lowest value we can get. 0. All right. So this, I would imagine, is saying, actually, let's look it up. So the best way to look it up, I would just do Arduino map. So Arduino map. And we can go in here. And so what it's saying, remaps a number from one range to another. Awesome. That is a value of from low will get mapped to too low. So what we've got here, so it's saying there's some value from a low, from a high, to a low, to a high. So if we're looking here, it's saying here's our pot value, whatever number that is. It can be between 0 and 1023. Change that to an equivalent of 0 to 179. Hopefully that makes sense. It's scaling it down to a number that it can better work with, that can directly relate to the servo. So you'll see when our potentiometer is sending out a pot value of 0, our servo is at 0 degrees. It's down at the bottom. And then if I rotate this all the way to 100, well, that says to 179. This is going to rotate 0 to 179, which is actually 180 because 0 is a value in there. So it rotated 180 degrees. All right. Now, if you wanted it to rotate more than that, you might be able to change these values. So I'm just gonna mess with that. Let's just say 300. Let's stop it. I'll try to remember 179. Oops. I'm not sure if that's going to work. This might be as far as it will run. All right, so it's running from 0. So I'm guessing it'll be exactly the same, and that's the farthest the servo can go. Yeah, so now it's saying an angle of 300. I'm guessing they entered 179. Yep. So they entered 179 because that is as far as the servo can go. It can go 180 degrees, right? I wanted to see if it could go more than 180, and it couldn't. So that's why they set it. Also, I guess proportionally that wouldn't have worked. So that is it. That's, if you want to read through the rest of it, obviously you can. I would suggest it. You will see on your setup, if you're doing this in real life, capacitors look a little bit different. If it's not working, once it's programmed, I would suggest unplugging the USB and then plugging your 9-volt battery into this plug. Hopefully your Arduino kit came with it, and then it should work. I I wasn't able to run mine for some reason. But I also didn't have my capacitors. So maybe those capacitors add to it. If you don't have capacitors, you might be able to get away with doing pretty much the same exact thing, just running it off the 9-volt battery. That might not be good for the servo though. So if it gets ruined, I'm sorry. I think it's fine as far as I know. Awesome. And then there's a gauge apparently. I'm guessing this is paper. So let me just check this. If it is paper, I'm not going to waste your time with it. Obviously, you can make it in real life. Awesome. So this one measures. Yeah, someone made it out of the CD. So you can make a little sign saying "keep out." This servos is how robots work. Servos are how a lot of really different cool things work. So that's about it. So hopefully you learned something. I will try to put out another one soon. See ya.